Welcome back. In this video, we will be exploring invoking commands and creating basic geometry. In our last video, we saved our drawing titled My Drawing to our desktop. Upon opening the AutoCAD software, the default AutoCAD template file has been opened and is currently titled Drawing 1. Let's close this drawing file by one of two methods. We can click on the X in the Drawing 1 File tab, or we can click on the X just up to the right of our view cube. We are now presented with the AutoCAD Start screen. And if we were to click on the box labeled Start Drawing, we would again open the default AutoCAD template file. By selecting on the down-pointing contextual menu arrow to the right of the word Templates, we are presented with a list of the current drawing template files that are stored in the folder location where the AutoCAD template files are stored in your computer. It is this folder location where we will eventually save our personal drawing template file. We will visit this folder location at that time. Left-click outside this contextual menu or hit the Escape key to close this contextual menu. Below the word Template is a typical Open Files icon. Selecting this will open your computer's File and Folder Navigation dialog box. Again, hit the Escape key or Cancel to close this dialog box. In the center of the Start menu screen is displayed a list of recently opened drawings. Left-clicking on any of the displayed previous drawing icons will open that drawing file. If your My Drawing file is listed here, left-click on it to open your previously saved drawing file. If you encounter an error, possibly because this selected drawing file has been moved or deleted, you will need to use the Open Files icon and navigate to the location in your computer where this drawing file has been saved. One tool palette that is essential to always have open and available is the Properties palette. To access the Properties palette, we can type Properties or simply PR and hit Enter in the command line. We can type Control-1 to toggle the palette on and off. We can navigate from the Home tab in the ribbon to the View tab in the ribbon, and over in the Palettes panel, we can click on the Properties icon to toggle the Properties panel on and off. Or in the pull-down menu at the right end of our Quick Access toolbar in the upper left-hand corner of our display, activate the Properties icon in this toolbar as a quick access means of opening and closing the Properties palette. The Properties palette is a powerful resource as it provides information about an object or a select group of objects, and depending on the objects, different means of modifying those objects. Right-clicking on the gray title bar of this palette, we see a number of options and settings we can apply to this and any other similar palette. To minimize the real estate these palettes take up on our display and still provide some flexibility, uncheck Allow Docking, check Auto Hide, left-click on the Prompt Transparency. In the Transparency dialog in the General section, move the slider down to 50%. Check the Apply these settings to all palettes box and click OK. This transparency setting allows the user to see any geometry that may be behind the palette. The Apply these settings to all palettes setting ensures that all palettes the user may access will retain these same transparency settings. Left-click and hold on the palette title bar and place it close to the edge of your display, but also so that it is not covering or blocking any other portion of the user interface. When we pull our cursor away from the palette, it closes down to show only the palette title bar. Hovering our cursor over the palette title bar prompts the palette to expand so we can review the contents and information. Let's quickly explore docking this palette. Recheck Allow Docking, and then select Anchor Left. Docking rigidly docks the palette and completely fills the display edge. Right-clicking on the docked palette title bar offers the user the option of minimizing the palette down to a single icon. This maximizes the drawing real estate, but the icon can be frustrating to accurately access, especially when on smaller displays. The text bar at the top of the Properties palette displays the type of object that is selected, and as appropriate, the total number of objects selected. When more than one type of object is selected, for example, one line segment and one circle, this text bar will display the word All, followed by a numerical value in parentheses, indicating that multiple unlike objects are selected. Left-clicking on the pull-down arrow at the right end of this text bar will reveal a list of the types of objects and the quantities of each type. Let's explore a sample of this and then use the Properties palette to modify the selected objects. Pan your display by pressing and holding down your mouse scroll wheel so that you can see the UCS icon and the point where the X and Y planes intersect. At the left end of the ribbon, in the Home tab, click on the line icon. Note that in the command line, it indicates that you are actively in the line command and the software is prompting the user to specify the first endpoint of the line. To reinforce the connection that this software is vector-based to coordinate points in space, left-click one time with your cursor in the command line and type 0, 0, 0 and hit the Enter key. This is an instruction back to the software to begin our new line at the coordinate point 0x, 0y, and 0z. The command line is now asking the user to specify the second or other endpoint of our line. Let's type in the command line 12, 6, 0 and hit the Enter key. The command line is assuming we want to continue drawing additional line segments. Since we are done drawing the line that we desire, hit the Escape key one time to exit the command. This second endpoint now physically resides at the universal coordinate point 12 units x, 6 units y, and 0 units in the z direction. Left-click one time on this line to select it. The selected object will now show as highlighted in blue and will display a blue square at each end and a blue square at the line segment's midpoint. If you do not see this end and or midpoint grips, recheck your Object Snap settings down in the Draw Tools toolbar and toggle on any of the recommended object snap settings discussed in the Navigating AutoCAD video. With this object selected, right-clicking expands the right-click contextual menu, which now contains additional modification commands such as erase, move, etc., which we will review in the next video. Note near the bottom of this contextual menu is another option for activating the Properties palette. Hit the Escape key one time to exit this menu. With this object selected, Shift right-clicking expands the right-click contextual menu, which now contains object snap icons along with some other commands. Selecting any of these icons will instruct the software to temporarily see and recognize that specific OSNAP type only. Hovering our cursor over the Properties palette, the Properties palette now displays information specific to this line segment. The top text bar tells us that this object is a line. Its color is by layer, and it lives on the 0 layer. We will discuss layers in depth in the next video. Looking further down the Properties palette in the Geometry section, note that the start X, Y, and Z coordinates match the start point we input in the command line. Likewise, the end X, Y, and Z coordinates match the endpoint we input in the command line. Note that for lines in the Properties palette, we are also given information in the delta or change in X, Y, and Z distances, the total length of this line, and the angle that the line projects. Note that the angle is a whole unit number based on the angle decimal place setting chosen in the Drawing Units dialog box previously. As such, this numerical angular value may not be wholly accurate. Left-click one time in the Start X numerical value box and change that value to 2 and enter, and the Start Y value to 2 and enter as well. Note the graphical change of the line object in model space and the delta length and angle values in the Properties palette. Navigate your cursor away from the Properties palette and hit the Escape key one time to deselect the line segment. A fundamental rule of any good habit to establish early is that every command or short series of commands the user executes is to save the drawing file. Losing unsaved work is never fun, so save your drawing. In the Home tab Draw panel, click on the circle icon. Note that in the command line, it indicates that you are actively in the circle command, and the software is prompting the user to specify the center point of the circle. Type 6, 12, 0 and hit the Enter key. The command line now prompts the user to specify the radius of this new circle. Type 3 and hit the Enter key. This new circle center point physically resides at the universal coordinate point 3 units x, 6 units y, and 0 units in the z direction. Left-click one time on the circle and one time on the line. Hover your cursor over the Properties palette and let it expand, and the top dialog box states all 2 with the number 2 in parentheses. Left-clicking on the contextual menu arrow reveals that we have one line and one circle selected. Using our cursor to scroll down and click on the circle allows the Properties palette to display only the information pertinent to the circle, such as the circle's center, X, Y, and Z location, the radius, diameter, circumference, and area. Drag your cursor to any random point in space in model space, left-click once, hit the Escape key one time to deselect the selected items. On occasion, the user may find it necessary to tap that Escape key more than once in order to deselect or put the pencil down. A quick comment regarding the command line. Typically, once the user begins typing a command, a flyout extends and displays a list of commands that contain the letters that have been typed to that point. Therefore, it is not always necessary to fully type out a complete command word. The user can alternatively left-click on the desired command as it is displayed in the flyout list. Another method of accessing commands is by typing in the search bar of the big red A menu. Same as with the command line, once the user begins typing, a flyout extends and displays a list of commands that contain the letters that have been typed to that point. Let's quickly examine some of the other draw tools within the Draw Tool panel on the Home tab. Ensuring that orthographic mode is turned on in our drafting tool settings at the lower right. Select on the polyline icon. We can also invoke this command by simply typing PL in the command line and hitting Enter. Similar to the line command, the command line is communicating to the user that we are in the polyline or P-line command and is asking the user to specify the first point in model space to begin drawing this polyline. In model space at a random location, left-click one time. The command line now asks the user to specify the next point. With orthographic mode active, note that our cursor movement or extension of this polyline is limited to the left, right, up, down directions. Choose a random point in any upward direction. Note that the command line continues to request for the next polyline point location and will do so until the user either presses the Enter key or Escape key to exit the command. Randomly select 4 or 5 additional points moving left, right, up, or down, and then exit the command. There is a distinct difference between the behavior of lines and polylines. Enter the line command, and above the recently created polyline, choose points in model space and create a series of lines similar to the shape of the nearby polyline. Hit the Escape key one time to exit the command and save your drawing. Let's quickly explore how to use your cursor to select objects other than directly left-clicking on an object. When the user left-clicks at a random point in model space, the software enters the selection mode. Any movement of the cursor in the right-hand direction creates a blue shaded pick box. In order for this selection box to select an object to be recognized, the object needs to be fully and completely surrounded and enclosed within the blue forward selection box. If the object is not fully enveloped, it will not be selected. When the user left-clicks at a random point in model space, the software enters the selection mode. Any movement of the cursor in the left-hand direction creates a green shaded pick box. Any object simply touched by this green back selection box is selected and recognized. One can think of the blue pick box as a more surgical method of selecting objects, especially as a drawing area may compose many objects in close relationship in model space. Selection with a forward blue pick box is a very intentional method of selecting an object or objects. The distinct difference between lines and polylines is the interaction of their endpoints. The endpoints of line segments may occupy or share common points in space, but the lines are physically separate and independent objects. The movement of one line or just an endpoint that shares a common point or coordinate with another endpoint will have no bearing or effect on the adjacent endpoint or lines. A polyline, on the other hand, is a series of connected line segments. The shared endpoints can be thought of as holding hands. There is a graphical or visual cue difference in AutoCAD that clearly tells the user if a particular line segment is a line or a polyline. Left-click in space up and left of the lines and the polyline that you have created, ensuring to fully surround the objects. And left-click again to release the selection box. Note that the midpoint of a line segment has a blue square box, and the midpoint of a polyline has a flat rectangular blue box. Left-click on the midpoint of one of the line segments. This midpoint will turn red, and if you glance at the command line, you will see that the software has automatically entered the stretch command and is requesting the user to specify where in model space the user wishes to stretch or relocate this chosen line segment. Move your cursor to relocate the line segment, and then left-click at the point in model space desired to place this relocated line. Note that even though the line segment moved, the adjacent line segments were unaffected. Left-click on a midpoint of one of the polyline segments. Again, the midpoint will turn red, and the command line will automatically enter the stretch command, prompting the user to choose a point to relocate the polyline segment. Left-click to place the line and exit the command. Note that the adjacent connected polyline segment endpoints stretched and moved along with the relocated polyline segment. Save your drawing. In the Home tab Draw panel, below the circle icon is a pull-down contextual menu. We can see in this contextual menu 6 different methods to draw a circle are given. These are common, but not the only ways to draw circles in AutoCAD. Center radius we have already explored, and center diameter functions in virtually the same manner. Remember that hovering your cursor over a tool icon for a few seconds will prompt an instructional pictorial to pop up directing the user how to use the tool. The 2-point and 3-point circle tools simply ask the user to left-click the points in which a circle is to be drawn. The Tangent Radius tool asks the user to specify the linear or curvilinear geometry segments the new circle is to be tangent to, and then to specify the new circle's radius. The Tangent tool asks the user to specify the linear or curvilinear geometry the circle's geometry is supposed to be tangent to. Again, save your drawing. In the Home tab Draw panel, below the arc icon, is a pull-down contextual menu, and here we are presented with 10 different methods to construct an arc segment. When constructing arcs, it is usually beneficial to deactivate or turn off orthographic mode, as arcs are non-linear geometry. The 3-point arc tool is rather straightforward. The user simply is instructed to select a start point, a midpoint, and an end point for an arc segment. Each of the other 9 arc icon tools offer unique solutions to generate geometry and solve design problems. These arc tools will be covered more specifically in a later video. In the Home tab Draw panel, the rectangle icon command, when invoked, in the command line the user is prompted to select by left-clicking a first corner point, and it is then prompted to select the second corner point. Once the second corner point is selected with a left click, the command automatically exits. We will take a moment here to review an alternative way to accurately instruct the software to generate geometry when the actual fixed coordinate points in space are not known. We will explore this using the rectangle command. Left-click on the rectangle icon in the Home tab Draw panel, or in the command line, type REC and hit Enter to enter the rectangle command. As prompted in the command line, select a point in model space for the first corner. Let's say that we want our rectangle to be 12 units wide and 6 units tall. And since we have chosen the first corner, we will assume this to be the lower left-hand corner of our rectangle. We want to type in the command line the @ symbol by typing Shift 2. In English language terms, allow the @ symbol to mean from where I started, go. This is a way to instruct the software to go or connect to a point relative to the chosen starting point. In this example, we have begun to draw a rectangle from a random point in space, and understand that we wish to have the opposite corner of our rectangle to be relative to this random point, 12 units in the x direction and 6 units in the y direction. So, in our command line, when prompted to select the second corner point, we want our typed expression to read at 12, 6, and then hit the Enter key. Interpreted into English, relative to the first corner of our rectangle, go 12 units in the x direction and 6 units in the y direction. Save your drawing. Back in the Home tab Draw panel, The rectangle icon has a pull-down arrow, which reveals the polygon tool. The polygon tool allows us to draw multi-sided polygons of an infinite number of sides. Upon selecting the polygon tool in the command line, we are prompted to input the number of sides of the polygon we wish to create. Here, let's enter the number 8. The command line then prompts the user to specify the center point or location for this new polygon. Here, I will select the center point of this circle for convenience, as I recall the radius value used to generate this circle. The command line then prompts the user to choose whether this new polygon is to be inscribed or circumscribed about the circle radius. If the polygon is inscribed, the endpoints of the legs of the polygon will touch the circumference of the circle radius specified. If the polygon is circumscribed, the midpoint of the flats of the legs of the polygon will touch tangent to the circumference of the circle radius specified. In the command line, we are presented with the options of selecting inscribed or circumscribed within a pair of squared brackets. We have the option of typing in the command line the capital letter I for inscribed or C for circumscribed and pressing enter, or we can place our cursor over our choice and left click. To the right of the squared brackets is a pair of carets. The option contained in these carets is the option the software will execute unless another option choice from within the squared brackets is made. Currently, C for circumscribed is within the carets, and hitting enter accepts this option. The command line then asks the user to specify the radius of the circle. In this instance, we can type the radius value, or we could select one of the quadrant points of the existing circle. We will type the known radius of 4 for this polygon and hit enter. Once completed, the command automatically exits. Hitting the enter key or the space bar automatically re-enters the last command. Upon entering the command, we see that the number of sides is preset to 8 within the carets. Hitting the enter key accepts this value. When prompted to choose the center of the polygon, we will choose the center point of the same circle we used previously. We will choose inscribed from within the squared brackets and then select one of the quadrant points on the circle to complete the command. In the Home tab Draw panel, the ellipse pull-down reveals 3 methods for creating an ellipse. Selecting the Center Ellipse tool, the command line first asks us to specify the center point location for the new ellipse. The user is then prompted to specify the location for the longitudinal or long axis endpoint and the cross or short axis endpoint. Selecting the axis end ellipse tool prompts the user to choose opposing longitudinal axis endpoints and then the cross or short axis endpoint. When specifying the longitudinal and short axis endpoints, the user has the option to enter numerical distances, as opposed to simply left-clicking points in model space. And, as we learned earlier in this video, adjustments to any of these geometries have the ability to be reviewed and modified in the Properties palette. The last tool to visit in the Home tab Draw menu panel is the Hatch command. There is a pull-down menu associated with the Hatch command. We will visit Gradient and Boundary in a later video. After invoking the Hatch command, either by selecting on the Hatch icon in the Home tab Draw panel, or by typing the word Hatch or just H and hitting Enter key in the command line, we see the ribbon change to a ribbon panel with tools specific to working with and modifying hatches. In the Pattern panel of the Hatch ribbon, there is a pull-down that reveals all of the pre-installed hatches that come with the AutoCAD software. The default hatch pattern is the ANSI 31 crosshatch pattern. In the command line, the user is prompted to select an internal or closed boundary point to apply the hatch to. The user is able to select within closed object volumes up until the point the command is exited, either by pressing the Enter or Escape keys. If the area selected is not closed, the software will return a dialog box warning stating a closed boundary could not be determined. Upon re-entering the Hatch command, we see in squared brackets the option to select objects. Again, what is important to understand about these options inside the squared brackets is that there is always, typically one, sometimes more, capital letter that can be typed as a keyboard shortcut to activate that command option. By invoking the Select Objects command option, the command line now prompts the user to select geometric profiles. Closed geometric profiles will be fully filled, whereas unclosed geometric profiles, such as this open polyline, can produce some very interesting and potentially unwanted output. One last point of note is that hatches placed in separate volumes but within the same command instance will be considered by the software to be one entity. We will explore these draw commands further and explore the various modify and annotation commands in the next video.